Good morning, everyone. My name is Raina Ghazi, and I'm the Teacher Development Manager for Macmillan Education International Curriculum. Thank you so much for joining our webinar this morning with Mohi Uddin, who will be focusing on place value. If you have any questions, feel free to write them in the chat box. You will be able to see one another's comments. Do try your best to stick to, of course, the topics at hand when you're using the chat box. Also, just in advance, the PowerPoint and the CPD certificate will be made available to you automatically once the webinar has finished. So I will pass it over to Mohi now. Thank you.
Hi everyone, welcome to this session. It's 10 a.m. here in London. Hopefully you're having a good day so far, and if it's afternoon or evening, hopefully this would be a good end to the day as well. I'm just going to share my screen to start off with so that we can get started promptly. There we go. So let me know you can hear me and everything is clear from your side. I'm going to, so I might have some strange angles. So this is my normal screen, my laptop screen, where I can see my presentation, and I'll start writing things with my pen, and hopefully you can just about see that. And this is my screen here where I look at whether you're writing anything. So I can see lots of positive messages, good mornings, and thank yous, and where you're joining from, which is brilliant. The more messages you can write, the better it would be for us, just so that we know that you can hear us clearly, and also that you can actually participate. You're participating in the session as well. So welcome to everybody from Muscat to Morocco, from India to Oman, which is brilliant. And I'm glad you can all hear me very well. Let's get started. So our session, I'm just going to press this button for a second. Our session is all on place value and how that can really result in an enhanced awareness and skills in addition and subtraction. It's really the building blocks of addition and subtraction, and more as well. But today's focus is on addition and subtraction. But we're also going to look at a few other things. So we're going to look at the introduction to place value, prerequisites of place value as well as addition subtraction in there, and a new, not new as such, but a catchphrase, blended learning, which is really getting popular now, mainly because I think the whole world is in this lockdown situation. So this is the main content of today: introduction to place value, addition, subtraction, and blended learning. So the first question I want to ask you really, gives me a chance to read your comments straight away, is why the need for place value? Why is there a need for place? Is there a need for place value? Why is there a need for place value? So have a think and have a look at that question, and do message me why you think there is a need for place value. Okay, I'll give you a minute just to have a think about that and type your response on our chat. Got lots of people, which is great. Hi Nishit from Rajasthan. Hello Nomsibo from Swaziland, Cape Town. This is our second session actually. So we've had one already about 2 hours ago, and it's our second session for this webinar of the day. And we've had lots of people from South Africa, Cape Town as well, UAE, in the previous session too. Right, so for understanding, so let's look at this question: why is there a need? Why the need for place value, really? Is there a need for place value? To understand order of numbers, says Sudha. Calculations, says Imad. Comparison of numbers, says Anju. To arrange them correct order as per the digits, says Radhika, I think it was. Sorry, the message just went above. Knowing the numbers for doing high operations. Nadia from Jamaica, welcome Nadia. To understand numbers properly and for calculations, ordering numbers, place values needed to identify the values of a number and a position. To do all 4 basic operations, place value is important as it helps us to order numbers. And a few others after that as well. Forming numbers better, you need to understand the order of a number. Okay, great. So we've got plenty of responses there. And all of them are correct. And in fact, place value is the value of each digit in a number. Why is there a need for place value? Well, I normally like to show you visual representation of why. So here you can see that lots of these red dots here. If I asked you to calculate how many there are or work out how many there are, you would count each single one of them, right? And if a child did this, is very likely they will miss one out or they will count one twice. And that would mean that whatever answer they give is most likely to be incorrect if they've missed one out or counted one twice. But if they've done both, then they'll probably get it right again. So place value is important because it allows numbers not to look like this, but to look more like this, being more organized, being more systematic, seeing things more clearly, and being more efficient at the end of the day, right? So here we can see that there's 3 rows of 10. If we count 1 row of 10, then we can understand that the next 2 are going to be 10 as well. And therefore we've got 3 10s and 3 and 3 6, 3 10s and 6 1s. That's going to be 36. Look how quickly we did that. Whereas here, we would take a bit longer and we'll be slightly unsure whether we've done it 100% right. So we may count again just to double check we did it right. And so it's inefficient because we're going to take double the time or more. We're going to count twice to reassure ourselves. Whereas here, once we count once, we are more than confident. So numbers are similar in the sense that abstract numbers, the way we see them can be like this. If we have lots of ones, 1, 1, 1, 1, 1, 1, 1, 1, up to 36 ones, that would be a nightmare, right? But we want it to be more organized so that it's easier to count for us, to understand and make sense of numbers. We can see more patterns and start to generalize things with place value. It's easier to compare numbers, as many of us have mentioned, used in number systems around the world. So whether I'm in England at the moment, whether I'm in England, or if I go to a different country, I know that majority of countries in the world now, if not all of the countries, have a base 10 number system. And so that would be used all across the world. And so it would be easier for me to understand. And it's something that's standardized now pretty much all around the world. It also allows us to calculate systematically, and in fact, having good place value knowledge and understanding from early age allows us easier mental arithmetics as well. So there are some key reasons why we must get place value right. I mentioned the base 10 system, and you might not be familiar with what I mean by that. But what I mean is when we have the place value columns, we start off, let's say, with ones, and then we have tens, then we have hundreds. I'm just gonna write hundreds like this, easier. Then we have thousands, 10,000s, 100,000s, and 1 million. And we go to 10 million. And what we need to realize, if we haven't done so already, and what we must make sure our kids realize, is that a base 10 number system means that there are 10 ones that make 110. There are 10 tens that makes 100. There are 10 hundreds that make 1,000. There are 10 thousands that makes 10,000. And the same for 10 lots of 10,000 makes 100,000, and 10 times 100,000 makes a million. And so this base 10 number system is evident in pretty much every country now in the world. And that's an important part that we have to kind of make clear, especially as our children get older. Do they know that 10 lots of tens makes 100? So when you ask your children how many thousands makes 10,000, do they straight away tell you 10 lots of thousands that make 10,000? If they don't, then they're not fully aware of the base 10 number system. But before we get into place value at a higher level, let's start off at the early stages of place value. So have a think about this question, 12 plus 6. How would you show 12 plus 6? What would you do with 12 plus 6 for your children for them to get an answer that you can understand, they understand what they're doing? How would place value have an impact on something like this? Have a go, give you a minute, and then we'll come back together. As you do that, I'm just going to read some of your messages. Good day, Mikisha Griffins from Jamaica. Nice to have you here, Mikisha. Because the writing is really small, I wonder if I can make this bigger. I don't think I can, but because the writing is really small of your names, I can't always read your names very clearly. So if I get your names wrong, do forgive me. So Gija says need to understand position of a number. Read that already. Ritupana says 1, 10, 2 ones, add 6 ones, tens and ones, use a number line, 1, 10, 2 ones, 6 ones, split into tens and ones. Great. So we've got a lot of different suggestions there, and quite a few saying split into tens and ones. What would you, so the question I'll throw back at you is, you're saying split into tens and ones. At an early stage, how would you split it into tens and ones? How would you show your children split into tens and ones? So Jayoti saying make columns and write tens and ones and write the numbers. That could be one option. Would that be one of your first options for early stages of place value? Would that be the best option for us to go into abstract where we write tens and ones straight away? Is there a step that we will take before then at an early stage age by showing demonstration? How would you show the demonstration, Shipra? How would you show the demonstration? What would you use? Demonstration means something that's physically there, right? Demonstration, right? Demonstrate. Use concrete things. Great, Ritu Parma. So let's getting down to it now. We're getting down to the gist of it. So use concrete things. Now again, throw it back at you. What concrete things would you use? With examples like counters, says I think this is Minnie. Minnie says examples like counters. Great. So something like counters. Blocks. Some of us may use base 10 blocks. Use manipulatives. What type of manipulatives? There's lots you can use. Everything's a manipulative. This pen I've got in my hand can be a manipulative. So what type of manipulatives? Seeds. So lots of things. Legos. So the question arises then is, what would be the most efficient thing to use? Okay, what would be the most efficient manipulative to use? Because we've gone through quite a few there, right? Dean's is an absolutely excellent resource to use, but can be quite formal and intimidating for the early stages, right at the beginning. But maybe there's a few steps before then. One of the suggestions I would, one thing I would suggest rather, is to use something like 10 frames. And here, we've got an app here, because we're going to focus quite a bit on blended learning. We've got an app here. It's called Number Frames, which is totally free. You can have a go at it yourself in your time. And this allows us to show 12 using something called 10 frames. So here I've got 10. What's 12? 12 is 10, 1, and another one. There we go. That's 12, right? 10 and 2 makes 12. And I think it was add 6, right? So we're going to add 6 to that class. So let's see. Let's get another 10 frame out here. I'm going to add 6. So I'm going to have 5 and one more. Okay, great. 10 add 6, or rather 12 add 6. So how am I going to do this? So some of us said split into tens and ones. So I can see 10 and 2 makes 12, and 6, you can see the 6 one on its own. So one of the things we've got to make sure our children are exposed to is the fact that numbers, when we use numbers, when we see numbers, we use them as abstract because we're quite older, right? We're older than our children. But numbers are to represent quite concrete things. And so we have to get back down to concrete. Now, in a world that we're living in at the moment, where there's a lockdown and we're teaching online, and you might be teaching online for the rest of the year. How do I use concrete? How do I become a teacher that uses concrete online? So you can use concrete online, like these sort of things. You can have a camera on top overhead view and recording your hands and things that you're kind of moving around, or you can use manipulatives like this app. And I will share the name of the app. I think it's there already. You can probably just about read it on the screen. But we'll go through the apps. Don't worry. Let's try and focus on the task ahead. So we've got this. What we need to realize is that the structure of numbers is so important. If we start to go through this with our children, so that when children look at numbers 1 to 10 first and then 1 to 20 next, they always see this. They always see that anything above a 10, like 11, for example, 11 is 10 and 1 is 11. 10 and 2 is 12. 10 and 3 is 13. When they see this every single day that they look at numbers, before you even mention the word place value, you're already getting your children ready for place value. So before formalizing teaching of place value, what we have to try to do in our schools is make sure that there are informal procedures ahead of place value itself. Without that, what's going to happen is you're going to jump into place value, and it's going to be a much bigger jump for our children. Some children will get it straight away, right? But you're not too worried about those children. It's the majority that are going to struggle at first. How can we support them? How did they see numbers before is the first question we have to ask. And with that comes the realization, hopefully, that number bonds. So here, seeing that, I can move these two here. So actually 12 add 6 is the same as 10 add 2 add 6, right? And I know 2 add 6 really quickly and easily. That's going to be 18. I can add the ones together. That gives me 8, and there's 1 10. That's 18. We can write that down as much as we want, and we can avoid seeing all of these visual representations. But this is a lot more complex than seeing this same thing in action using concrete. When we show using the concrete materials, what we do after that in terms of the abstract, which is here, makes a lot more sense for our children. If we jump to abstract first, that's going to confuse a lot of our children. So if we jump to tens and ones first, that can confuse our children. But if we do the same thing, like we've done here, then what would happen, what would be great, is if we do the same thing here, but then we write tens and ones here, and that way, what would happen is that our children will be able to see why we have the answer we have. So before even thinking about place value, we have to get number bonds right. In fact, so many of the top performing nations use their time in the early stages of maths lessons to make sure that children master number bonds. In fact, because the Max Maths series that Macmillan Education have is based on the Singapore Maths approach, I can tell you that Singapore spend 2-3 months sometimes, right, depending on the cohort, on number bonds itself. They're willing to spend a huge amount of time in the academic year just getting number bonds right. Why is that? That's because research shows that those children that struggle in maths in the later years of their primary education, they are the ones that are quite weak in number bond knowledge. Those who are strong in the number bond knowledge, they actually do quite well in maths. So that's something for you in your school, in your region, to think about. How are we preparing our kids to have strong number bond awareness, and so that they won't struggle in maths in later years? A part of the number bonds awareness is this what we call a part whole diagram. Some of us call it a number bond diagram as well. And this just shows us that in this case, 5 green apples and 3 red apples together makes 8. So we've got 2 parts here, 5 green, 3 red, makes 8 altogether, the whole. So we call it the part whole diagram. And with this comes a lot of positives, because then we can talk about the fact families very easily. So for example, if I've got 5 and 3, the 2 parts are 5 and 3 that make 8. If I get rid of the 3 red parts, what are we left with? We can visually see that 8 take away 3 equals 5. But we can also see 3 add 5 equals 8, and 5 add 3 equals 8. But 8 take away 3 is 5. Or if I take the greens away, 8 take away 5 equals 3. Now, this specific example is not that important. It could be any number. But what we want our children to realize is, if I've got a whole made from 2 parts, if I take one part away from the whole, I'm left with the other part. If I take one part away from the whole, I'm left with the other part. And that is a really important lesson, because this comes in about year 1 when we talk about fact families. And so number bonds, fact families, these are all really important aspects before we even start to get place value right. So prerequisite really of place value is to make sure we see and visualize numbers so that our children can really see the structure of numbers that will allow them to be amazing mathematicians by the time you get to place value, and they will just understand place value a lot quicker, and it'll be a lot more simpler for you as a teacher. So here's a task I want you to try out. You've got the number cards 1, 2, 3, 4, and 5. I want you to place the number cards in these 5 positions so that the vertical sum is the same as the horizontal sum. But obviously they're cards, so if you put the number 1 somewhere, you can't put it anywhere else. How many different solutions can you come up with so that the vertical sum is the same as the horizontal sum using the number cards 1 to 5? I'll give you 2-3 minutes to try that out. The previous class, no pressure on you, at 7 o'clock did really well. So, I want to see how you guys do. Going to read some of your messages. So we've got one response already. Great. We've got 2. So we've got 5, 1, 2, and 4, 3, 1. So I'll write some of these down. So we've got 5, 1, 2, 4. Ooh, that doesn't make sense. Or 4, 1, 3, you mean? 4, 1, 3. Is that right? Yep, I think that's one solution. Any other solutions? Oh, we've got 1, 3, 5, 2, 3, 4. 1, 3, 5, 2, 3, 4. That's another solution. So we've got first solution here, second solution here, and maybe one more solution would be good. So 5, 3, 1 with 5, 3, 1. Yeah, we've got that one already. 5, 3, 1, 4, 3, 2 is just written 2, 3, 4 the other way around, but it's fine. It's the same. Is there any other solutions? Do we have any more? We've got 2 solutions. Looking for maybe one more that's different. 5, 3, 1, 4, 3, 2 we've got already. Three, 4, 5, 1, 4, 2. I want you to double check on that one. Sudha, does that work? 3, 4, 5, 1, 4, 2. Does that work? Andrew's got one. 4, 5, 1, 2, 5, 3. Let's see. 4, 5, 1, 2, 5, 3. Is that right? Does that work? I think it does, right? So we've got 3 solutions now. And we'll stop there for a second, okay? Let's stop there. Let me get rid of these and let's have a think. Okay, so we've got 3 solutions to think about. Now, when we look at these 3 solutions, we can see that when we add the vertical number cards, 4 plus 1 is 5, plus 3 is 8, 5 plus 1 plus 2 is 8. And so in this one, the sum equals 8. In this one, the sum is 5 plus 3 is 8, 9. Sum equals 9. And in this one, the sum is 3 plus 2 is 5 plus 5 is 10. And so in this one, we've got sum as 10. Just drop my very expensive pen. But here we go. Right. So we've got 3 different solutions, which is great. And the sums of those solutions are also different. 8, 9, and 10. Brilliant. But when we look into this, can you see that there's a few things here. One is that your numbers in the middle are all odd numbers. There's no even numbers. Is there a reason why that we don't have any even numbers in the middle? Maybe you can think about that as an extension, but we won't do that right now. Other things are, look, have you noticed how the outside numbers vertically and horizontally, 5 and 2 horizontally is 7, 4 and 3 is 7, 2 and 4 is 6, 1 and 5 is 6, 4 and 1 is 5, 2 and 3 is 5. So the vertically opposite numbers and also horizontally opposite numbers, they form number bonds, right? In this case, number bonds to 7, or number bonds to 6, or number bonds to 10, right? And so this is really important, because if you're very positive with your number bonds, then you're going to be happy with this, right? You're going to be able to catch this quickly. Why does that work? Because they all share the middle number. And so if the outside numbers are, the sum of the outside numbers are the same, then it's going to work because they all share the middle number. So there are plenty of activities where using, getting your kids really, focus on number bonds. Even an activity like this is going to help them to really improve their place value knowledge. So let's go back a step. How does all of that help with a question like 19 add 16? Because if our children are confident with our number bonds knowledge, then what's going to happen, right? Let me just refresh this. What's going to happen is when we get to 19 add 16, we're going to have something like this. Let's look at this. 19 add 16. Hopefully you see this on your screen. So I've got 19 is 10 and 9. Let's get rid of this 9. And 16 is 10, a 5, and a 1. Great. Okay. So Here we've got 19 add 16. If we've worked heavily on the structure of numbers and how number bonds up to 10, so number bonds to 10, something like 9 and 1, 8 and 2, 7 and 3, and so forth. But number ones up to 9 is 5 and 4, 6 and 3, 8 and 1, so forth. If we've done that for a while, what our children will realize that actually this question of 19 add 16 is actually the same as if I move this one here, 19 is just one off the 20, and 16 is a 10 and 5 and 1, or 10 and 6, and I can move this one to the 19 to make 20. So this is the same. 19 add 16 is the same as 20 add 15. I can take one from the 16 and give it to the 19, and I'll have 20 and 15. And that mentally is a lot easier to do, right? 20 add 10 is 30, add 5, 35. That mentally is easier to do. So not only are they using their place value knowledge here, but they're using a number bonds knowledge here to use their place value knowledge here to be able to be more efficient, and they can all do that mentally as well. So that's the kind of level we want our children to get to, right? But how does that work? Well, firstly, before we look at place value, we have to look at number bonds. And once we look at number bonds in a positive way, then when we get to place value, they're going to be a lot more flexible with their numbers. They're going to be able to manipulate numbers a lot better. And that way, it will work out a lot better for you and your children in your class. So what resources are you using is a question that I would ask you as well. Have a think about that. What resources are you using? Because looking at the Cambridge International Curriculum, the progression shown from year to 6, hopefully you can see in front of you right now. And in fact, what we see is that from year 4, to year 5, there's a big jump, right? From 10,000 to 1 million. But all the others, 20, 100, 1,000, 10,000, then a big jump, and then it stays the same in year 6, which is up to 1 million as well. So, bear that in mind. What do we use? How do we represent millions the same way we represented numbers in year 1? So year 1, this might be great for 10 frames, the ones I showed you just now. It might be good to use deans, which are also known as base 10 blocks. But would you use the same 10 frames to represent million? Of course you wouldn't, right? It just wouldn't make sense. You'd have the whole class full and you still wouldn't be near 1 million, right? So therefore, we have to make sure we use the right resources. So initially, you might start to use things like sticks, 10 frames, and deans, and showing visually how 10 ones is equal to 110, right? Visually showing that, articulating that verbally, getting your kids to writing it down so they are very confident and they can see and that they've got it in them. But then as the numbers get larger, you're going to start using things like the deans or base 10 blocks. You're going to start using place value counters and place value cards as well. And these are your early stages. You look at the 10 frames. And so how could we do that? Thinking about blended learning, the situation we're in requires us to approach this with that in our back of our minds as well, right? Surely, yeah. I know that some schools in some countries, actually, the government has already told everyone clearly that the rest of the academic year is going to be online, right? You're not going to be back in school. So if you're one of those countries, then you're going to be really thinking about blended learning a lot more, right? And online learning a lot more. And so here, This is another app that we use. It's called Number Pieces. You'll get a list of the apps that I've used today and other apps that I suggest that I haven't been able to use today for whatever reason. And so you'll get a list of that, and you can you'll get it on the PowerPoint as well, and you can take a picture if you wanted to. And this is a great app for you to use for blended learning, because literally you've got the base 10 blocks in front of you, and you can manipulate them pretty much as you want in any way, shape, or form. So, for example, I've got 300. Maybe I want to take away 120. Okay, so I'll show I've taken away 100. That turns red. How am I going to show? I'm taking away 20. I'll click this button, and I'll make the 100 into groups of tens, and I can show that. I'll take away 20 here, and there you go. And if I want to show that they're taken away, I might want to show it in red. I've taken 120. Maybe I want to take 123. I can get another one of these tens. I can split that up into ones, and I can take that away, and I can show that I've taken away 123. Okay, and that way I can use something like this to represent my concrete materials. It says, can you share the screen? I think you should be able to see my screen. I'm not sure what you mean by that. And so, yeah, this is a great app for addition, subtraction, place value, asking questions, seeing numbers, even multiplication and addition as well, sorry, division rather as well. I use this for long division, believe it or not, to visually show what's happening in long division and why we subtract and so forth. This is perfect for that. So this is called Number Pieces. And like I said earlier, I'll share all the apps that I've been using, and I'll share that later on because I've got another slide for that. So one of the key features of the Max Maths series is the fact that we use the CPA approach. And if you're not sure what that means, it just stands for the Concrete Pictorial Abstract Approach, which I've written right about here. Okay, and all that means is we try to, whenever we introduce new ideas, new topics, we, especially at that time, try to show these ideas, these concepts, using concrete materials. So whether that's it could be Dean's, it could be Lego, it could be place value discs, it could be whatever you have that's physically concrete that you can manipulate. Obviously, in this day and age now, current situation, it would have to be something you can manipulate online, like the apps that I've shown you. They're great for the current situation. And so it encourages teachers and children to play with maths with their hands. The first step to understanding maths is to be able to manipulate it with your hands, then in your mind. The quicker our children experience that manipulation with our hands, then the quicker they will get it in their minds too. Seeing maths really helps us to master maths. So encouraging children to use concrete materials is really important. So we'll have to be a bit more innovative, in terms of the way we are teaching at the moment. So whether that is you get your children to try to do this at home, or you make a video and they can see it and they can do the same thing at home, that's something that will probably be different in every school, especially with the policies that we have. This is a task that we didn't get to do in our last session, so I think we've got just about enough time now to do this. What I'd like you to do is use the number cards 1 to 9. So if they're number cards, that means if you use the number card 1, you can't use it again, right? Use the number cards 1 to 9 to fill up these spaces so that you have two-digit numbers that make a 3-digit number. Now, I could do 1, 2, 3, 4, right? I'll get 2 plus 4 is 6, 1 plus 3, or could I? 1 plus 3 is 4, but I've already used 4, so I can't do that. And even if I didn't use 4, if I have, let's say, 5 here, that would be 7. I can't do that because even though I haven't used a 4 here, it doesn't give me a 3-digit number. So the task here is use the number cards 1 to 9 to make two 2-digit numbers that give a sum that is a 3-digit number. I'll give you 5 minutes, 3 to 5 minutes. Try that out. How many different sums can you make? So don't forget to write down the answer as well. So if you do 92 add 13, make sure you write down the answer so I can write it down. Wow, I've got quite a few. That's quick. Got quite a few. I'll pick some of them out. So give you 2-3 minutes to get used to that. Some of us might not be getting many. Oh, someone's got 80. Is that possible? Can you have 80? You can't have 80, can you? Because why can't you have 80? Because I've said the number cards 1 to 9. But don't worry. Everyone asks me, can I use 0? Normally when I'm doing this in your obviously before webinars, even during webinars actually, we've trained schools all over the world. So with Macmillan, I think the last session we were in, I think it was Saudi Arabia, if I'm not mistaken. We went to Egypt, Saudi Arabia, Oman, Bahrain, if I'm not mistaken. Is it Oman? I think we've been to Oman actually, Bahrain, a few other places. When we're delivering face-to-face training, we always get asked this question: can we use 0? And I normally say no, you can't use 0. Until after a few minutes, I say, okay, let's use 0. Okay, so you can use 0 now. Okay, so I'll give you a chance to use 0. See if that makes a difference. Is 0 something that is actually productive for us by using 0? Okay, so we've got a few here. I'll take a few. So 56 plus 73. Oops. 129. 73 plus 69. 142. What else? 42 plus 95. 137. Okay. Okay, so we're getting quite a few. Okay, here's another challenge. Okay, now that you've got loads of solutions, I haven't checked all of them, so I'm hoping you haven't made any mistake, class. Okay, so now that you've got loads of different solutions from all around the world, literally in this case, what I would like you to do is I would like you to work on the same problem. So you're still creating two 2-digit numbers that give you a sum that is a 3-digit number, but with one difference now. Can you make the largest sum? What is the largest sum for this problem? So have a go at that. So we've got 142 so far that I've seen. Maybe there's others that I haven't seen, but we've got 142. That's the largest so far. That's the largest sum we've got so far. What's the largest sum that you can make? You can have a 0 in the answer. That's fine. Ooh, someone said 98 plus 99. Can that happen, class? Tell them why it can or can't happen. Ooh, someone said 876 add 123. Can that happen, class? Tell them why. Yeah, right. So you've got 9 3 times for 98 add 99. Okay, you can only use the number cards once. Someone said 98 add 76. What's the answer to that? Someone says 183. Is that possible, class? 97 add 86. Is that possible, class? Tell them why. Because you've got the 8, right? Twice. It's okay. Don't have to be sorry. We're just having fun here. Maths is fun. No need to apologize. Okay. So I'll give you another minute. Let's see who's got the largest sum. Ooh, someone's saying 515. Is that even possible? To add two-digit numbers and get 500? Could that be possible? What's the largest two-digit number? 99. If we add 99 twice, which you're not allowed to in this, do we get 500? It's not possible, is it? Someone's got 174. Is there any larger numbers than 174? So in this, so we've got another minute left, and then we'll go through this and we'll kind of wrap up our session, and then we can have a Q&A session. So class, 174, some of us are saying, right? 179. Is that possible, class? 179. Aisha, can you think about that? Is it possible? 156. 89 plus 77, 156. It's okay. Don't be sorry, Sudha. No one needs to be sorry. Okay. So, last 30 seconds. Let's see. Someone's got 183. Is that possible? 97 add 86, 183. Is that possible? There's something that we repeated there. Looks easy, but it's tricky. Very true. That's right. We're not supposed to repeat the number. 168. 187. Is that possible? 99 plus 88. Well, 99 straight away. We've got two nines there. You can only use, these are number cards. If you use the 9 once, you can't use it anywhere else. Remember that. Okay, so let's stop for a second. Okay, let's go through this together and let's understand this problem a bit more, because this comes back to place value. Okay, the last question that I set comes back down to place value. And this is why, because I asked you to work out the largest sum for this problem. And in order for us to have the largest sum, that means for the digits that we have 1 to 9, we have to use the largest digits for the tens column. Is that right? Does that make sense? So what are the largest digits for the tens column? 9 and 8. 9 and 8 are the largest. What does 9 add 8 tens give us? That gives us 17. Is that right? That gives us 17. And thankfully, 1 and 7 haven't been used. So let's think. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can add the 0 as well. We've used 9. We've used 8. We've used 7. We've used 1. Now, with the remainder of the digits, what's the largest sum I can make with the ones? If I add 2 and 3, that makes 5. Is that the largest? If I add 3 and 4, that makes 7. That's not possible. If I add 5 and 6, that's 11. We've already used 1, so we can't use that. What about 4 and 2? That gives us 6. So 4 and 2, 6. The largest sum we can make here is 176. 94 add 82, 176. But also, someone wrote 84, not 94. 84 add 92. So another trick we might have used is, if we've got one solution, then I can just manipulate this and move the ones or the tens over, and I'll have another solution. 84 plus 92, 94 plus 82 is also 176, right? So I've got, if the task was the winner is the person that makes as many correct solutions, that might be a quick way to make many solutions, right? If you've got one, we instantly have 2. But you can hopefully appreciate this problem a bit more once we've gone through it. Place value here is knowing the actual, thinking about the question at hand, knowing that I'm trying to make the largest sum, so that must mean that the tens value, which is the largest value in a 2-digit number, has to be my largest values, which is 9 and 8, largest digits, 9 and 8, which thankfully gives us 17, and I can use the rest to make the ones. So as someone said, this looked like quite a simple question, but actually it was quite tricky, right? And just like the previous question where we had the vertical and horizontal sum, what we call low floor, high ceiling tasks. What does that mean? It means that a low floor, high ceiling task is one where it's easy to access because it's low floor, it's a low floor. That means it's easy to access, but it has a high ceiling, meaning that we can take our children really far up. We can ask different questions. So for something like this question, we could have asked, why was it that only the middle numbers are only, odd numbers rather than even numbers and odd numbers, right? That's a really challenging question. In this question, we could have said that, we asked you that, find the largest sum, again, challenging you further, okay, than what you were expecting. And some of us struggled with that. That's not a problem because that's the whole point. We want, if maths is always easy and we got it straight away, then it'd be pretty boring. We wouldn't need teachers either, right? So this was a challenging problem, which hopefully you enjoyed, and you can benefit from that in your classrooms as well. The Maths Max Maths rather series that Macmillan have is absolutely amazing because all of the things that we've discussed today, the visual representations, as you can see here, the discussions, a major part of Singapore Maths is discussions, which are encouraged in the books, variation in terms of the questioning, using manipulative as well as enhanced support for your children, for those who have language barriers, slightly more than others. They can listen to audio as well. So all of those key features, including the features where numbers get a lot larger, they're not missing visual representations pretty much on every topic, so that your children can not only understand maths, but they can really accelerate their understanding and really thrive in maths lessons because of the CPA approach and many other approaches within the books. In this session, we don't have enough time for this question. And so we'll kind of stop there and I'll just start wrapping up. In our first session, we went through this one and we didn't go through the previous one. And here, you can kind of see that we're coming back to the CPA approach and getting us to think about the CPA approach, concrete, pictorial, abstract. Is it possible for us to have a blended learning environment and the CPA approach? That's something for you to think about. Don't forget, when we're teaching our maths lessons this year, whether it's online or face-to-face or a mixture of both, then try to think about in your planning representation, which is the visual aspects, concrete aspects, generalization, number sense, communication, and metacognition. Try to have as many of those elements as possible in your maths lessons. Remember that seeing maths helps us to master maths even in a blended classroom. The apps that I used today, I used number frames, I used number pieces. I didn't use number lines, but they are from the same company. This company has like something like 8 or 9. It's not a company, it's a charity. It's an American charity. They have like 8 free apps online. So you can use them on your browser like I did, or you can download them on your Chrome app store if you use Chrome, or even on your iPad store. They're all free, which is brilliant. There's also another app that I didn't use, which is Place Value Discs. And this is a paid app, and I think it's only on iPad. I don't think it's on Android. So that's a really good app as well. That's for like larger numbers, the Place Value Discs. I think goes up to 1 million, if I'm not mistaken. And they're great. That's paid. It's not a huge amount, but and it's not my app or anything. I don't make any money out of this, but they're great apps. And Algebra Tiles is also great for negative numbers and algebra as well. And that's also fantastic. So just for you to kind of maybe think about if you needed them. So we're going to go for a Q&A session. We've got about 5-6 minutes before our Q&A session. So please feel free to ask any questions right now. And here's a few more details about how you can contact us, and more information about some of our products. You can check out our social media links, our website, as well as email international.curriculum@macmillaneducation.com if you need more assistance or you're interested in one of the products that Macmillan have. I don't see many comments, so I don't know if you've gone to sleep in my session or you're really deeply thinking. I like to think you're having deep thoughts in your mind about this. Thank you, Shipra. It's an excellent. Thank you for your comments. Questions would be really great now. You don't have to ask questions, but feel free to, if you have any questions in your mind relating to this actual session. So I'm not going to answer any questions that are away from this session, but if it's this session, it would be great for you to ask now. Thank you, Anju and Deepika and Yasmin and everyone for your lovely comments. I'm glad you found the mind teasers, Kamal. Thank you, all of you. If you have questions, feel free to ask away. I'm here to help you. I'm here to support you. We're all here at Macmillan to support you. You can definitely teach regrouping, addition, subtraction through the Number Pieces app. Thank you for taking part, Raki, and hopefully you can use what you've learned today straight away in tomorrow's session. You'll also get the presentation, if I'm not mistaken, from Raina very soon. I think, if I'm not mistaken, as soon as this session is finished. If you want to take a picture of the slide here, if you wanted to do that, that's also fine. I'll leave that there for a few more seconds as you kind of finish off. Thank you so much for a good presentation. Thank you so much. It was really good information. Thank you very much. Thank you. Thank you. Thank you for all your positive comments. Thank you, Shipra. Thank you for attending. I think we've got another session next month, middle of next month. I'm sure the details are on the website, and hopefully you've signed up for that. I can't remember off the top of my head what the topic was on, so maybe Roina can help me out. Great, you've already registered. And I think maybe even next week, that might be select regions, though, where we have another session for those already using Macmillan Education's Max Maths series of books. So if you haven't already looked into Max Maths series of books, get in contact with your local representative, and I'm sure they would love to go through it with you. I think that's about it in terms of questions. So thank you so much for your wonderful feedback. And I think I'll pass it on to Raina, if I may. Raina, are you there?
I'm definitely here. I was just waiting for you to come on. Don't worry, I haven't fallen asleep or anything. Just in case you're worried. Thank you so much, Mohi, for a great, fantastic session. We had a session earlier this morning as well, and I think it really helps when our attendees are engaged and they can ask questions to Mohi. He is a Singapore maths expert, so this is really useful and beneficial to have professional development with Mohi, and also, of course, to have attendees who are really benefiting from the session. As Mohi mentioned, we do have webinars coming up. We do have one next week, which is for Max Maths user schools, which is on the 21st of September. And also we have another session with Mohi focusing on Max Maths assessment, which is at the end of the month. So as always, feel free to contact us if you have any questions. The PowerPoint and the CPD certificate will be available at the end of the session. So if you don't have any questions for now, we will say goodbye. Thank you so much for joining. Thank you to Mohi. Stay safe, and we look forward to seeing you join a session in the coming weeks. Take care. Bye.
Bye.